Module 4. Supply Chain Management. The dynamics of supply chain management, ensuring efficiency and resilience. Supply chain management is a crucial element of modern businesses that deal with the coordination and optimization of various processes, from the sourcing of raw materials to the delivery of finished products to customers. It plays a pivotal role in the success of companies across industries by ensuring efficiency, cost-effectiveness, and adaptability in the face of dynamic market demands. Supply chain management encompasses the flow of goods, information, and finances from suppliers to manufacturers, distributors, retailers, and finally, the end consumers. It involves a network of interconnected entities, and efficient coordination among them is essential to meet customer demands while minimizing costs and inventory levels. A well-optimized supply chain can lead to enhanced customer satisfaction, increased competitiveness, and better financial performance. Supply chain management has 5 key components. The first is sourcing and procurement, which involves identifying reliable suppliers, negotiating contracts, and ensuring timely delivery of quality raw materials at competitive prices. Strategic sourcing can lead to cost savings and improved product quality. Production is another key component of supply chain management. The manufacturing process is a critical part of the supply chain, involving efficient production planning, capacity management, and quality control to meet demand while minimizing waste. Distribution and logistics focus on efficiently transporting goods from manufacturers to retailers or end consumers. It includes warehousing, inventory management, transportation, and order fulfillment. The fourth component of inventory management involves balancing supply and demand as essential to avoid excess inventory or stockouts. Effective inventory management ensures the right products are available at the right time and place. Information technology and data analytics is the final component of supply chain management. Leveraging technology and data analytics helps in real-time monitoring of supply chain activities, forecasting demand, and identifying areas for improvement. Supply chain management is significant because it impacts various aspects of the organization's operations, performance, and overall success. Supply chain management can improve efficiency and reduce costs by streamlining processes and reducing inefficiencies. SCM can lead to cost savings for businesses and consumers alike. An efficiently managed supply chain ensures timely delivery and availability of products, enhancing customer satisfaction and loyalty. It is also crucial for a supply chain to be well designed so it can adapt quickly to changing market conditions, reducing the risk of disruptions and uncertainties. SCM fosters collaboration among supply chain partners, leading to better coordination, communication, and decision-making, ensuring economic, social, and environmental viability through sustainable operations and supply chain management. The concept of sustainability has gained significant importance as businesses and societies recognize the urgent need to address environmental and social challenges while ensuring long-term economic viability. Sustainable operations and supply chain management encompass a holistic approach that integrates economic, social, and environmental considerations into the core practices of an organization. Sustainable operations and supply chain management begin with economic viability. Organizations must ensure that their practices are financially sound and contribute to their long-term success. The social dimension of sustainability focuses on people, encompassing the welfare of employees, communities, consumers, and other stakeholders. Environmental viability is fundamental to sustainability, as organizations must reduce their ecological footprint and promote environmental stewardship. Sustainable operations and supply chain management demonstrate the inherent interconnection between the 3 dimensions of sustainability. For example, sustainable practices often create shared value by simultaneously benefiting the organization's financial performance, supporting social welfare, and preserving the environment. In the realm of operations management, one of the critical metrics used to evaluate the efficiency of a production process is the throughput ratio. This ratio provides valuable insights into how well a system utilizes its resources to generate output, which is crucial for businesses aiming to maximize productivity and profitability. In this essay, we will delve into the concept of the throughput ratio, its calculation, and its significance in optimizing operations. The throughput ratio, also known as the flow ratio or flow efficiency, measures the proportion of time that a system spends adding value to a product or service compared to the total time spent in the system. In essence, it quantifies how effectively resources are used in the production process. The goal is to maximize the throughput ratio, as a higher ratio indicates a higher percentage of time spent on value-adding activities and less time on non-value-adding or wasteful activities. The throughput ratio can be calculated using the following formula. Throughput ratio equals value-adding time divided by total lead time. The throughput ratio, TR, is the ratio of the total processing time for the job divided by the total waiting time plus the total processing time. Value-adding time refers to the time spent on activities that directly contribute to the creation of the final product or service and add value from the customer's perspective. Examples include manufacturing, assembling, or processing components. Total lead time refers to the total lead time that encompasses the entire process, starting from the initiation of the production until the final product or service is delivered to the customer. It includes value-adding time as well as non-value-adding activities, such as waiting, transportation, inspection, and rework. Customer queues, managing waiting lines for enhanced customer experience. Customers expect efficient and seamless experiences when seeking services or purchasing products. However, in many service settings, customer queues or waiting lines are an inevitable aspect of daily operations. Whether it's in retail stores, banks, airports, healthcare facilities, or amusement parks, queues are a common occurrence. Effectively managing customer queues is crucial to ensuring positive customer experiences, optimizing service delivery, and maximizing customer satisfaction. This essay explores the significance of customer queues, the factors influencing wait times, and strategies to manage queues for enhanced customer experience. A customer queue, often referred to as a waiting line, is a sequence of customers who are waiting for service or to complete a transaction. Queues can form due to various factors, including limited service capacity, uneven customer arrival patterns, and variability in service times. These waiting lines can have a significant impact on customer perceptions and overall business performance. Several factors influence wait times. The first is service capacity, which is the number of service providers available, and their efficiency in handling customers directly affects queue lengths and wait times. Insufficient service capacity can lead to longer queues and frustrated customers. Another factor is arrival patterns. The variability in customer arrival rates can result in fluctuating queue lengths. Peaks and lulls in customer arrivals can lead to unpredictable wait times. Service time variability is the third factor. The time it takes to serve each customer can vary due to the complexity of service requests or individual preferences. Longer service times contribute to longer queues. Lastly, we need to consider queue structure. Different queue structures, such as single-line or multiple-line systems, can influence how customers perceive wait times and their overall experience. For example, if a bank has an average of 10 customers per hour arriving into the system, and it takes an average of 30 minutes for the clerk to complete a transaction with a customer, the average wait time is 5 customers. To calculate the average length of the queue in the bank, we can use Little's law, which states, average queue length, or LQ, equals arrival rate, abbreviated as lambda, times average time a customer spends in the system, or W. Given the information provided, the arrival rate, lambda, is 10 customers per hour. The average time a customer spends in the system, W, is 30 minutes per customer, or 0.5 hours. Now, let's calculate the average length of the queue, the LQ. LQ equals lambda times W. This 10 customers per hour times 0.5 hours, or 5 customers. So, the average length of the queue in the bank is 5 customers. The connection between supply chain management and customer queues lies in the efficient allocation of resources, both within the supply chain and at customer service points. An optimized supply chain reduces lead times and ensures products are available when and where they are needed, minimizing the chances of stockouts and customer dissatisfaction. 2 fundamental supply chain strategies: innovative and imitative. Supply chain management plays a pivotal role in determining the success and sustainability of an organization. Companies must carefully devise supply chain strategies that align with their objectives and market demands. 2 fundamental approaches that companies often adopt are innovative and imitative supply chain strategies. A focus on originality, creativity, and cutting-edge technologies characterizes an innovative supply chain strategy. Companies adopting this approach prioritize developing unique products or services and designing novel supply chain processes to deliver exceptional value to customers. Key features of an innovative supply chain strategy include: innovative companies allocate significant resources to research and development, driving breakthroughs in product design, manufacturing processes, and logistics management. This enables them to differentiate their offerings from competitors. These companies invest heavily in understanding customer needs and preferences. They leverage customer insights to tailor supply chain processes, ensuring speedy delivery, customization, and responsive service. An innovative supply chain is built to be agile and adaptable. It can quickly respond to changes in demand, market trends, or disruptions, giving companies a competitive advantage. Innovative supply chain strategies are more open to taking calculated risks, embracing disruptions as opportunities for improvement rather than threats. The imitative supply chain strategy, as the name suggests, involves mimicking successful practices or products already established by competitors or other industry leaders. Companies that adopt this approach focus on replicating proven supply chain models to capitalize on existing market demand. Key features of an imitative supply chain strategy include: companies keenly observe their competitors and industry trends to identify successful supply chain practices worth replicating. As the core concept already exists, the implementation process is typically faster than developing an entirely new approach. Imitative strategies often require fewer resources and reduced R&D investments, leading to cost savings. Imitating established practices can reduce the inherent risks associated with innovation. Manufacturing. Manufacturing setup plays a pivotal role in the efficiency, productivity, and quality of production processes. It encompasses the arrangement of machinery, equipment, tools, and resources required to manufacture products. A well-organized manufacturing setup is crucial for meeting production demands, optimizing workflow, and ensuring cost-effectiveness. Firstly, a well-designed manufacturing setup enhances efficiency. Placing machines and workstations strategically can minimize unnecessary movement and transportation of materials, reducing production lead times. It allows for a smoother flow of work, enabling higher throughput and faster completion of tasks. This efficiency leads to reduced production costs and increased profitability for the company. Secondly, an organized manufacturing setup improves productivity. By carefully planning the layout and flow of materials, it becomes easier for workers to access the resources they need, reducing downtime and idle periods. This increased productivity translates to higher production volumes and shorter manufacturing cycles, allowing companies to meet customer demands more effectively. Additionally, an optimized manufacturing setup promotes better quality control. By ensuring that workstations are equipped with the necessary tools and resources, companies can minimize errors and defects in the production process. Quality checks and inspections can also be integrated into the setup, allowing for timely detection and resolution of any issues that may arise during manufacturing. Furthermore, an efficient manufacturing setup enables companies to be more flexible and responsive to changing market demands. When the production process is well organized, it becomes easier to adapt to fluctuations in customer requirements and product variations. Companies can quickly reconfigure the setup to accommodate new products or make improvements, staying competitive in a dynamic market environment. Process flow charting, a comprehensive guide to visualizing and optimizing workflows. Organizations face the constant challenge of streamlining their processes for increased efficiency and productivity. Process flowcharting emerges as a powerful tool to analyze, document, and optimize workflows across various industries and sectors. In this essay, we will explore the concept of process flowcharting, its significance, and how it aids organizations in identifying bottlenecks, enhancing communication, and improving overall performance. Understanding process flowcharting. Process flowcharting, also known as process mapping or workflow diagramming, is a graphical representation of a process or system that uses standardized symbols and arrows to illustrate the sequence of events and decision points. This visual representation breaks down complex procedures into simple steps, making it easier for stakeholders to understand the workflow and identify areas for improvement. This often involves describing an existing process. If a new system is being developed, this can be omitted. There are three key components of process flow charting, which are symbols, sequence, and decision points. Each step or activity in the process is represented by a specific symbol. Common symbols include rectangles, for processes, diamonds, for decision points, circles, for connectors or starting/ending points, and arrows, to show the flow of the process. The order of activities is presented chronologically, helping stakeholders understand the flow of work from the beginning to the end. Decision points represent moments in the process where choices must be made, leading to different paths or outcomes. Creating process flow charts. Creating a process flow chart involves 5 steps. The first step in process flowcharting is to select an appropriate transformation process for analysis. This involves selecting the specific process or workflow you want to map out by defining the scope and objectives of the flowchart. The next step in the process involves gathering information. This can include engaging stakeholders who are familiar with the process to collect relevant data and insights by understanding each step, decision point, and the order of activities. After the appropriate information has been gathered, we choose the appropriate symbols to represent different elements of the process. Ensure consistency in using symbols throughout the flowchart. Then the symbols are arranged in the correct sequence, connecting them with arrows to depict the flow of activities. The last step is to review and refine the chart by validating the flowchart key stakeholders to ensure accuracy and completeness. Make revisions as needed based on feedback. Common flowchart symbols, a comprehensive guide to visualizing processes. Flowcharts are valuable tools for visualizing complex processes and systems in a simple and easy to understand manner. To effectively communicate and analyze workflows, standardized symbols are used to represent various elements within the flowchart. In this essay, we will explore the most common flowchart symbols and their meanings, enabling individuals and organizations to create accurate and coherent flowcharts for process analysis, improvement, and communication. The oval or terminator symbol is used to represent the start or end of a process flowchart. It indicates the beginning or conclusion of a particular process, providing clear boundaries for the flowchart scope. The rectangle symbol represents a process or activity within the workflow. It is used to describe specific actions or tasks that take place in the process, such as data entry, calculations, or decision-making points. The diamond symbol denotes a decision point within the process flow. It signifies a situation where the process branches out into different paths based on specific conditions or criteria. Typically, yes or no questions are asked at decision points, leading to alternative courses of action. Arrows or flow lines connect different symbols in the flowchart, indicating the direction of the process flow. They show the sequence of activities and the logical progression from one step to another. Circles are connector symbols used to join flowchart elements that are located on different pages or sections. They serve as linking points to ensure continuity in complex flowcharts. The delay or half-moon symbol is used to illustrate a time delay or waiting period within the process. It indicates a point where the process temporarily stops before continuing to the next step. The document or pentagon symbol represents a record or document within the process flowchart. It indicates where data is stored, referenced, or documented during the process. The data or cylinder symbol is used to represent data storage or a database within the process flowchart. It indicates where information is stored for retrieval or use in subsequent steps. Off-page connectors are used to link flowchart elements that are on different pages or sections of the document. They provide a way to maintain flow continuity in large or complex flowcharts. Forecasting. Forecasting is a critical aspect of business and economic planning that involves making informed predictions about future events or trends based on historical data, current conditions, and relevant variables. It enables organizations to anticipate potential outcomes, identify opportunities, and prepare for potential challenges, providing them with a competitive advantage in a dynamic and uncertain world. Businesses use various methods to forecast future events, such as sales, demand for products, or financial performance. Time series forecasting, which relies on historical data to identify patterns and trends, is commonly employed when dealing with quantitative data over a period. On the other hand, qualitative forecasting techniques involve subjective judgments and expert opinions, particularly useful when dealing with new product launches or market shifts without sufficient historical data. Effective forecasting has numerous benefits. For one, it aids in resource allocation and capacity planning. By accurately predicting future demand, businesses can adjust production levels, inventory, and staffing to meet customers' needs efficiently. Moreover, forecasting assists in budgeting and financial planning, allowing organizations to set realistic targets and allocate resources optimally. It also enhances supply chain management, as suppliers can plan their production and deliveries based on anticipated demand. Forecasting is not without its challenges. Accuracy is a primary concern, as errors in predictions can lead to costly consequences, such as stockouts or excess inventory. External factors, such as changes in the economy, consumer behavior, or technological advancements, can add complexity to the forecasting process. However, organizations can mitigate these challenges by using a combination of forecasting techniques, continuously updating data, and employing experienced analysts. Forecasting weekly demand. If a company has the following weekly demand figures: in week 1, the demand is 20. In week 2, it's 60. In week 3, the demand goes back down to 30. And in week 4, it's down 20. By week 5, demand goes back up to 40. Using a 3-week moving average, let's calculate a forecast for week 6. To calculate the 3-week moving average forecast for week 6, we take the average of the demands for week 3, week 4, and week 5. The week 3 demand is 30. The week 4 demand is 20. The week 5 demand is 40. The 3-week moving average equals week 3 demand plus week 4 demand plus week 5 demand, divided by 3.
So, the 3-week moving average equals 30 plus 20 plus 40, divided by 3, or 90 divided by 3, which is 30.
So, the forecast for week 6 using a 3-week moving average is 30 units.